All right, this is the 4-1 warm-up. So the 4-1 notes were all about transforming our shapes through reflection, dilation, translation, or rotation, and then also determining if they're congruent. So we just said that they're congruent unless there's a dilation. So a transformation keeps it congruent, a reflection keeps it congruent, and a rotation keeps it congruent. But a dilation would change the size of it, so those two shapes are no longer congruent. So for number 1, it just says to take x and y and multiply each one by 3. So your A becomes 0, 3. Your B changes, or B prime changes to 6, 3. And your C to 6, negative 3. So you're just multiplying each of those by 3. The second part is to describe the transformation, and this is a dilation because we've changed the length of those sides. So if I was to compare those would not be congruent.
So all you have to write is dilation.
You could say dilation by a scale factor of 3. So if it wants you to describe the scale factor, it's how's it change, which is a multiplication of 3.
So if y was 2, it would be a dilation of...
On the x of 3 and on the y 2. All right, so number 2 says xy has changed to negative yx. So if you look at your translation, transformations, I'll make a Quizlet of this because this is good memorization, right? We've switched the position of the y and the x and changed the sign on the y. So if you look through here, this is the one that we're referring to. The x became the one on the point on the right, and the y changes sign. And that's a rotation about the 0, 0, 90 degrees counterclockwise. So that's your transformation. I'm going to switch the x and the y, and I'm going to change the sign on the y. So this one becomes negative 3, 0. The negative 3 went to the first spot, the 3 went to the first spot, and I changed the sign. This becomes negative 2, 1, and this becomes negative 5, 4. So you're switching the x and the y, and then after it's switched, you change the sign on the y. And we just said that this is a rotation. About 0, 0, which means it's moving around off of the center, 90 degrees counterclockwise. Questions on that one? Okay, and then 3, you're taking the x and you're adding 1 to it, and the y subtracting 2 from it. What kind of transformation is this? It's a translation, and it is 1 unit right, because that's the x change. Right would be positive, left would be negative, and 2 units down, because the y is being subtracted, or you're doing y minus 2. So A prime, I add 1 to the negative 2, I get negative 1, and I subtract 2 from the 1, I get negative 1. B prime, add 1, subtract 2, and I get negative 1, 2. And C prime, add the 1, subtract the 2, and I get 1, 1. So there is a graph there, which means you could have asked you to actually graph it. You could have seen the rotation or seen the dilation or seen the translation. But without a graph, you want to still be able to identify those points. So you didn't need the graph unless it says to obviously graph both the pre-image and the image. And sometimes you won't have a graph, which means you want to make sure you can identify it from what's written there as well. Ryan?
If it's a rotation, do you always have to put it in and see if it's a 90 degrees?
It actually, depending on the type of change, right? It's either a 90 degrees clockwise, and that's if the x and the y changes, but the x changes sign. And then there's a rotation counterclockwise, that's a switch, but the y changes sign. And then if they both change, it's a rotation 180 degrees. It's going to flip it upside down. So depending on what's being done, we'll show you which one.
I have to memorize that?
Yep. All right, so then 4 and 5 are determining whether the triangles are congruent. So remember, a translation, a reflection, a rotation keeps it congruent, but a dilation changes it, makes it not congruent. So you want to compare these points to each other. So A to J, B to K, and C to L. Sometimes it's easier to line them up right underneath each other. So if I were to do that, this is 1, 1 became 2, 2. 1, -1 became 2, -4. And 3, 0 became 6, 0. So are you adding or subtracting the same thing from these? No. Are we switching them around, like to have the X and Y change position? No. What do we think's happening? Multiplying by 2. Both of them are being multiplied by 2. The X got multiplied by 2. Everybody see that? The Y got multiplied by 2. If you don't see that, like just by looking at the numbers, then take the second one and put it over the first one. So 2 over 1, and that's 2. And then do that with the X's on this one. 2 over 1, that's 2. And do that with the X's on the third one. 3 over 6, that's 2. That right there tells you the scale factor on the X. And then go back and do the same thing for the Y's. 2 over 1, that's 2. -4 over 2, that's 2. And 0 over 0, even if you multiply that by 2, it still doesn't change it. So that gives you what your change is, and that's a dilation, which means that these are not congruent. You got to be more specific than what?
Any of that. What did you even do?
I compared the second points to the first point, right? So these on the bottom are all the second coordinates. You see that? I just rewrote them. Like this one is here, this one is here, this one is here. I just rewrote them underneath the matching one. And then I look to see if I'm adding the same thing to every term, which you're not, right? I'm adding 1 on the X's for A, adding 1 on the X's for B, but when I get to C, it goes from 3 to 6, which is not adding 1. So I know it's not a translation. So you don't know what you're adding. You look at 1 to 2. What would I add to 1 to get to 2? 1. Now go to B. I go from 1 to 2. Would I also add 1? Yes. Go to C. I go from 3 to 6. Am I adding 1? No. So now I know it's not a shift. It's not a translation. Then you want to look and compare your X's and your Y's. Have they switched positions? And no, I went from 1, 1 to 2, 2. That's not a switch of position. Which means your other option is dilation. And so I would take each X of the second set of points and put it over the X of the first set of points. And that's what's up here in the top. Every single one of them, when simplified, is 2. So I know that's the dilation on X. And then I did the same thing over here for the Y's. And every single one of them, with the exception of 0, because 0 would go unchanged, is also 2. So that's the dilation on the Y. So once you figure out that it's a dilation, you've got to figure out what the scale is. And because a dilation means it's not congruent, then I know these two are not congruent. Let me do another one. So 5. Okay, A went to D. So -1, -2 went to -2, 2. B went to E. So 4, -2 went to -5, 2. And C went to F. 1, -4 to -2, 0. So look at all of the X coordinates. So this, and this, and this. What do we know changed? Is it an addition or subtraction? So if I go from 1 to -2, what happened there? -3. Go to 4 to -5. Is that a -3? No. So I am ruling out my translation. Okay? Have my X's and Y's switched? No, because then the first one I've got 1 and -2. The second one I've got -2 and 2, which means I've ruled out my rotation. Does everybody understand that? Yes. So then what's happening if I divide? Actually, I can already tell they're not congruent, because if they're not one of those methods, right, they're not congruent. So this might not even be something that is a fixed dilation or dilation. As long as it is not translated or rotated or reflected, I know that that's not congruent.
Oh, so if you have to multiply something by like a number,
Then it's no longer congruent. Yeah. If you can rule out transformation, reflection, and rotation, it's not congruent.
well, why would it be congruent?
Because you're not adding the same thing to both terms. You're not switching the negatives and the positives. That would be your reflection. And you're not rotating. The X and the Y's have not been switched location. These are literally different values. I went from 1 to -2 and 4 to -5. That's not the same shift. So they're not congruent. If you had a graph and you plotted those points, you'd see they'd be two totally different size shapes. That's one way to do it. But you won't always have a graph, so you've got to be able to identify them without it. All right, so again, this is 1 through 6 from your homework. Number 1 said that it is a translation. 2 units to the left and 3 units up. Okay, we took the X, subtracted the 2, that's your 2 units left. We took the Y, added 3, that's your 3 units up. Number 2 is a reflection over the Y-axis. If you look at the signs on your X values, every single one of them flipped. Number 3 is a rotation about 0, 0, 90 degrees clockwise. So this time, the X and the Y changed position, and the X got the negative, which means it's a rotation clockwise. Number 4, this is a dilation with a scale factor of 2. So each of them you'd multiply by 2. And then number 5 and number 6 are just identifying if they're congruent. So 5, yes, they're congruent. It's a shift by translation. And number 6, this is, you clearly can see those shapes are totally different size, right? That would be a dilation, which means that those are not congruent. Dilation with a scale factor of 2 for 4. All right, 4-2, classifying triangles. Today's the day you get to feel like a genius.
Yay.
All right, so we're going to figure out, that's again something that hopefully we've learned before, so this should be a review, but if not, then today's your day to learn how to classify a triangle by its lengths and its angles. So definition of a triangle is a figure formed by 3 segments joining 3 non-collinear points, okay? They have to be non-collinear because otherwise you're drawing a line. The point where the segments meet is called the vertex. The plural of the word vertex is vertices. And then the sides are segments, so be careful when you name them. They are segments. They are not lines. They are not rays. They are segments. They start and stop. So we'll use that little symbol for triangle to make our lives easier. That's how we would write the name of this triangle. It could be triangle ABC. It could be triangle BCA. Or it could be triangle CAB. Those are all the same triangle. The order of the letters does not matter when you're naming it. The vertices are points. So A, comma, B, comma, C. That's point A, point B, and point C. And then the sides are segments. So segment AB, segment BC, and segment CA, or AC. The order of those letters don't matter either. And the angles are where those two sides meet. Each vertex forms an angle, or there's an angle at each vertex. So because those angles would be angle A, angle B, and angle C. All right, so there's 2 ways to classify a triangle. One is by its angles and one is by its sides. So by its angles, there are 4 different types of triangles. There are acute triangles. Think acute, little, acute, okay? Every angle is less than 90 degrees. Obtuse has 1 angle greater than 90 degrees. A right triangle has 1 angle equal to 90 degrees. And equiangular means that all the angles are equal to each other. That's by side, so that's next. This is by angle. So by angles there's 4, by sides there's 3. And then on the bottom there, you've got your pictures. So acute triangle, again, all 3 angles will be less than 90. Right triangle, one of the angles is going to be equal to 90. Obtuse, 1 bigger than 90. And equiangular, all of them would be the same. All right, so first example just says classify the triangle by its angle measures. So we're classifying the big triangle, triangle ADC. What would we call this triangle? A right triangle. That's it. Super easy, right?
Wait, but I thought right angles are 90.
Yeah, this one is a 90. This one's 90. The 100 is on the inside. The 100 is this angle here.
But
This one says classify triangle FHG by its angle. So F is here, H is here, G is here. It's equiangular. How do you know that?
Because all sides are, all angles.
All angles are the same. What do you have to figure out first in order to know that, though?
They all have.
Because there's no number at the top, right? How do you know what that angle is?
They're 60
How do you know?
equals 180. Yeah. All 360 is equal.
Okay, so you could go that way. That has that up to 180. The other one is that if this is 90
Right.
and this is 30, then that means that the top is 60, right? So you could look at it either way. So this is equiangular.
Wait, so if it was EFG, would it be a right angle?
EFG?
Yeah.
EFG's a line. EFG's a line. You mean EGH?
Oh, yeah.
EGH would be a right triangle. Yeah. All right, second way to classify a triangle is by its sides. So this is scalene, isosceles, and equilateral. Scalene, no sides the same. So every side has a different length. Isosceles is at least two sides the same. And equilateral is all three sides are equal. And then there's your pictures down on the bottom. So scalene, none of them are marked as congruent. Isosceles has two marked as congruent, and equilateral has all three marked as congruent. Okay, true or false? All isosceles triangles are equilateral. False. True or false? All equilateral triangles are isosceles. True. Why? At least. So the words at least mean 2 or 3. Okay, so 3 is EHF. So EHF is this triangle here. How would we classify that? Isosceles. This is where you get tested on your spelling skills, right? No. As long as I can figure out what that word's supposed to be, I won't mark you wrong.
Wouldn't that also be a right triangle?
But we're not doing, no, actually. So I'm glad you said that. You don't know for sure that that's a right angle. Without that little right angle mark, you can't classify it as right. All right, this one, EHG. So EHG is now your big triangle, which I have 12 on one side, 11 on the other, and this would be 14. What does that tell you? Scalene. Raise your hand if you got it right.
Wait, couldn't you have just done it so it's like 12, 10, 4, and you don't, and the back difference, so you could just say the scaling?
Yeah, that's fine. ACD is this little triangle right there. And we know this is scalene. So not only does it look different, but this 15 matches this, which makes this 15. And then I've got side lengths of 15, 5, and 18, which are all three different. And now look at this one. So it says to find the side length of triangle JKL. So we're bringing back in your algebra skills, right? So if you look at this diagram, what do I know about this triangle? It's isosceles. The two sides that are marked as congruent are JK and KL. So I would set those two equal to each other. 4x minus 10.7 would equal 2x plus 6.3. I totally disregard the one on the bottom. I don't need it until I plug it back in to find the length. So to solve for x, I don't need that yet. So then from here, I could subtract the 2x. And I get 2x minus 10.7 equals 6.3. Add the 10.7. 2x equals, this is 17.0 or 17. And then divide by 2. Good. X is 8.5 or 8.5. But it didn't ask me to solve for x, right? What was the question at the top asking for? To find the side. So I've got to take that 8.5 and do what with it?
Plug it in.
Plug it back in. Because I can plug it into either one of these, because they are the same, right? I can plug them into both and check, or I could just pick one. Let's say I do 2 times 8.5 plus 6.3. And this is 17 plus 6.3, or 23.3. That would be the side of JK and KL. And now I need that bottom side, JL, which is 5 times 8.5 plus 2. So 8.5 times 5 is 25. That's 40. Plus the 2 is 42. 2 and 1 digit behind the decimal. So this is 42.5 plus 2, or 44.5.
Wait, is that point by the 5?
Times. This is a times. Times. So JK is 23.3, KL is 23.3, and JL is 44.5. Questions on that one? All right, so because it's equilateral, all three sides are the same. You could pick any pair of sides in order to show that they're congruent to solve for y. So let's just say I picked GF and GH. So 3y minus 4 would equal 2y plus 3. Subtract the 2y. Y minus 4 would equal 3. Add the 4. And y equals 7. So you should have gotten the same answer no matter which of the other methods that you did, okay? Y equals 7, which means I have to take that and plug it back in. Does it matter which one you plug it back into? No. So if I had an extra 2 minutes on a quiz, you could plug it into 2 different sides to make sure that you're right. But if you're short on time and you're 100% right that is y equals 7, then it doesn't matter which of these sides you plug it in because all 3 sides should be the same. So I'm just going to take this one, 2y plus 3, 2 times 7 plus 3, which is 14 plus 3, which is 17. So we're saying that this is GH, FH, and HG. All 3 of them have the same length. Raise your hand if you got it right. Okay, good. Questions on anything related to today's notes? Yep.
So for the answer, would you just write y equals 7?
Not y. It says find the lengths of the sides. So you're saying GH equals 17, FH equals 17, and GF equals 17. You've got to give the side length.
17?
You got to take the 7 and plug it back in.